Hi students, welcome to today's lecture on artificial neural networks. Till now we have completed the first 3 units for mid-1 exam, and because the examinations were postponed, today we will start the 4th unit, which is about multi-layer feed-forward neural networks. So in 3rd unit, we have discussed about the perceptron neural networks, which consists of a single neuron, and we have seen how a perceptron neural network learns itself with the help of the perceptron learning rule, and then we have designed a few perceptron neural networks for simulating the behavior of AND gate, OR gate, and so on. Okay. In this unit 4, unit 4 is all about multi-layer feed-forward neural network, which is also called as multi-layer perceptron networks. Okay, so the difference between the previous unit and this unit is we see number of neurons in each layer with the feed-forward neural network, and the neurons will be connected with one another, and the direction of flow is always from forward direction towards the forward direction. Okay, so we'll see the differences between the perceptron and this feed-forward neural networks in a way. So in this class, we will be discussing about a simple introduction to what are feed-forward neural networks, and later we will see how many types of feed-forward neural networks are there and how they are different from each other. What are the possible activation functions, and what kind of learning algorithms will be used with this feed-forward neural networks. Okay, right. So let us start our topic. We'll begin with a simple introduction to what is a feed-forward neural network. So, feed-forward neural network is an artificial neural network where the connections between the nodes of the neural network do not form a cycle. So you should not see a cycle in a feed-forward neural network while the connections are formed. Therefore, feed-forward neural networks are also called as directed acyclic neural networks. Okay, directed acyclic neural networks. So this is the basic meaning you need to understand what is a feed-forward neural network is. And the second thing what you need to remember is, as we know, perceptron network is the simplest one among all the neural networks that contains a single neuron. Among multiple neurons, this will become the first and simplest type of artificial neural network, where the information moves only in one direction. What is the direction? In forward direction. So the information always flows like this, from one neuron to another neuron, always flows from the layer I to layer I+1 only. Okay, there is no going back. The information will never flow back in a feed-forward neural network. Okay, so this is the main property of feed-forward neural network. The information moves in only one direction, that is forward direction, from the input nodes, starting with the input nodes. These are the input nodes, and passes through the hidden nodes. If at all any hidden layers are there, it passes through the hidden nodes, and then it reaches the output nodes, finally producing the outputs from the neural network. Okay, so during this entire process, you should not see any cycles or loops in the neural network. So overall, the major point that you need to understand about feed-forward neural network is it is a directed cyclic neural network, which means that there are no cycles in the network. Okay, and the number of hidden layers depends on your application requirement. You may or may not have a hidden layer. Sometimes without having a hidden layer, you may be using single input layer which is directly fed to the nodes of output layer. Okay, so it is also possible. We'll see in a short time how these single layer perceptrons or single layer feed forward neural networks will be designed, and also how multi-layer feed forward networks will be designed. This example is an example for multi-layer feed forward neural networks. Okay, so this is a simple introduction to feed forward neural networks. Right. So let us start with the single layer feed forward neural network. What is meant by a single layer feed forward neural network? So this is the simplest kind of feed forward neural network, which consists of single layer of output nodes only. So you need to remember this point. How many layers of output nodes are there? Single layer of output nodes are there, and it will not have any hidden nodes. Hidden layers are not there. So what is the key point you need to remember here? There are no hidden layers. Okay, so this is the point you need to remember. There are no hidden layers. And the thing you need to remember is, since there are no hidden layers, the inputs are directly fed to the outputs. Okay, via a series of weights. So since there are no hidden layers, input neurons or inputs are directly fed to the outputs of a output layer neurons. Okay, so we'll see it, the architecture of this single layer feed forward neural network in our next slide. Okay, and then how do you calculate it? The weights of the neurons will be calculated as sum of the products of the weights which are connected to a particular neuron. Okay, so at each node, at each neuron, the value will be calculated as sum of the products of the weights, multiplication of the weights, and then based on the value, if the value is above some threshold, then the neuron fires. Otherwise, it takes a deactivated value. That means it will not fire. Okay, so we'll set up a threshold value for each neuron, and based on the calculated value, whether the neuron fires or not will be selected. Okay, so this is done by the activation function. Okay, generally the activation function selected for this purpose are called as artificial neurons or linear threshold units. Okay, so the other names for this kind of activation functions are artificial neurons or linear threshold unit. Okay, but generally you remember that perceptron means that consisting of just one of these units. That means if it contains only one neuron in the entire network, we can call it as a perceptron. We saw this perceptron networks in our third unit. We discussed about the learning rules also. Okay, so this is about introduction of single layer feed forward neural network. You can watch this diagram here, where single layer perceptron consists of uh, one output layer. There is only one output layer. This is the output layer. Okay, and you can see there are no hidden layers here. Inputs are directly fed to the output layer with the help of x1 is the input, and from this it is connected to input layer. This is input layer. From the input layer neuron simply forwards the inputs. Therefore, x1 is forwarded to all the neurons that are connected. So how do you calculate the actual value of this neuron? It will be calculated as, because it is connected with the x1 w11. So it is calculated as x1 into w11 plus x2 into w21. Watch this. This is the connections we have. X2 into w21 plus this one. From where it is coming? From xn into Wn1. So this is sum of weights of products x1 xi into wi. Okay, so the output of this neuron will be calculated as x1 into w11 plus x2 into w21 plus so on xn into wn1. Okay, so like that we will calculate the net output of this neuron, and then actual output produced by this neuron will be by sending this sum to an activation function selected. Generally, activation functions that will be selected for feed-forward neural networks uh, should support the derivation calculations. Therefore, generally it will be taken as a logistic function or sigmoidal function. Okay, so once the sum is forwarded to the activation function, it produces a value uh, according to the activation function selected, which we call it as y1. Okay, so y1 is the final output of this neuron after going through an activation function also. Okay, similarly, how do you calculate sum of this neuron? Because it is connected like this, the arrow is showing w12, therefore x1 into w12 plus this arrow is x2 into w22 plus so on xn into wn2. Okay, so these products will be summed up to get the output of this neuron, which will be forwarded to the activation function to get the final output work. Okay, and so on. This neuron will be calculated as x1 into w1m plus x2 into w2m, because these are the arrows connecting the weights over here, and so on xn into wnm. Okay, so that will form the sum of products, which is the net output of this particular neuron, which will be forwarded to the activation function to get the output of this neuron as ym. Okay, so this is how the inputs are summed up uh, after multiplying with the corresponding weights that they are connecting, and forwarded to the next neuron or next link. So this is a simple example for your single layer feed forward neural network, where we consist of only one output layer, which is directly fed to the input neurons through some weights. This is what we explained in the previous slide. Okay, there are few more things that we need to understand about this single layer feed forward neural networks. They can be trained by using a simple learning algorithm or learning rule, which we discussed in second unit. That is called as delta rule, where we calculate the error term and as the difference between the actual output calculated and the desired output. And then based on this error term, we will update the weights, we will make some adjustments to the weights. Then based on the adjustments, we will calculate again and so on until the error is minimized. Okay, so we already saw this delta rule in second unit. We practiced some problems also. So generally, perceptrons are trained using any of those basic learning algorithms such as delta rule. Okay, and then single layer perceptrons are only capable of learning linearly separable patterns. We already see this as a disadvantages of the perceptrons, because they can only uh, be designed if the input patterns are linearly separable. We saw this also in third unit. Okay, and when you get an input pattern which are not linearly separable, then it is always difficult. It is impossible. It is impossible to design a single layer perceptron network uh, for the corresponding input patterns which are linearly inseparable. So an example for linearly inseparable input data is XR, where we cannot separate the input patterns with a straight line. Okay, so this is an example XR. We will see it later how XR can be identified as linearly inseparable. Okay, so as of now, AND gate and OR gate are linearly separable functions, whereas XR is not a linearly separable function. Therefore, we cannot design a perceptron network for this XR. Okay, this is already proved by the authors Marvin Minsky and Seymour Papert. So it was already proved that it is not possible to design a single layer perceptron network for XR simulation. Okay. And coming to the activation function, generally the activation function that is selected for single layer feed forward networks is going to be logistic function or sigmoidal function. Uh, Instead of using a step function, we will make use of a sigmoidal function or logistic function that is represented as f of x is equals to 1 by 1 plus e power minus x. Okay, so by using this logistic function, we generally calculate the final output of a neuron in single layer feed forward neural networks, or generally in feed forward neural networks, this logistic function will be selected. Okay, so remember this. This is the activation function we are going to select for feed forward neural networks, because it is very easy to apply partial derivation on this function. Okay, so it is very easy to apply. So whatever activation function you select for feed forward neural network, that should be easily differentiable. That should be easily differentiable. Then only we can work out with this feed forward neural networks, because the back propagation algorithm makes use of derivatives or partial differential equations. Therefore, the activation function that we select should support that operation. Okay, so by using this logistic function, we can say that our single layer feed forward neural network is similar to the logistic regression model, which is used in statistical analysis purpose. So this is same as a logistic regression model then. And this logistic function or sigmoidal function, as we know, produces a shaped graphs that resembles the S letter, the sigma letter, and we saw it in first unit. We have seen the graphs of this also, and because of this particular function, the logistic function is widely used in back propagation algorithm. Okay, so we'll practice this back propagation algorithm in this unit itself. We start learning this feed forward network design. Okay, so because it allows a differential equation or continuous derivative, the logistic function will be changed like this. F dash of x after derivation, you can write like this: f dash of x is equals to f of x into 1 minus f of x. Okay, so this will be the derivative of uh, the logistic function that we selected. Okay. So what we discussed in this is what is the activation function we are selecting, and then what is its derivative. Just try to remember these two. F of x is equal to 1 by 1 plus e power minus x is the logistic function or activation function we are selecting, and this is the derivative of the activation function we are selecting. This activation function directly is useful for us in uh, forward pass while implementing that back propagation algorithm, and this will be useful for us in backward pass while implementing the back propagation algorithm. We'll see that in our next session. Yeah, so till now we discussed about the single layer feed forward neural network, and now let us understand what is a multi-layer feed forward neural network. So as the name suggests, multi-layer feed forward network consists of some hidden layers, one or more hidden layers. Okay, one or more hidden layers. So in its basic form, it consists of one single layer, one hidden layer, and one output layer. Okay, in single uh, layer feed forward neural network, the input layer is directly connected to output layer, whereas in multi-layer feed forward neural network, there is at least one hidden layer appears between input layer and output layer. Okay, so you can see the connections also here. The connections are from input layer to hidden layer. Okay, every neuron is connected to every neuron of hidden layer, and then the connections from the hidden layer to output layer if it contains a single hidden layer. Okay, suppose if the network contains more than one hidden layer, then it looks like this. These are input layers. X1, X2, X3 are input neurons, and S1, S2 forms the first hidden layer. S3, S4, S5 forms the second hidden layer, and the output layer contains Y1 and Y2. So this is a sample of multi-layer feed-forward neural network, which consists of more than one hidden layer. Okay, you can have any number of hidden layers. If the number of hidden layers increases, then it becomes a deep neural network. Okay, and always remember that this is a feed-forward network. Therefore, the information always flows from the input layer to output layer only. The direction is always forward direction, and the connections are always from layer I to layer I plus 1 only. Okay, there is no backward connections between the neural networks. That means you cannot have connection from layer 2 to layer 1. It's not possible here in feed forward neural networks. So that is the reason why in this diagram you have connection from x1 to s1, x2 to s1, x2 to s2, x3 to s2, and so on. S1 to S3, S1 to S4, S2 to S4, S2 to S5, and so on. All the connections in this neural network are feeding forward only. They are moving forward only. Okay, the direction of flow of information is forward direction. Okay. Yeah, let us understand the important points about this multi-layer feed forward neural network now. The class of multi-layer feed-forward neural network consists of multiple layers of computational units, as we saw in the previous diagram. And each neuron in one layer has directed connections to the neurons of subsequent layer. That is always from layer I to layer I plus 1 only. Okay. So in most of the applications, the units of these networks uses a sigmoidal function as activation function, as we saw earlier. Just like a single layer feed forward neural network uses sigmoidal function or logistic function, this multi-layer feed forward neural network also makes use of sigmoidal function or logistic function as an activation function. Okay. There is a important theorem that we should understand related to the feed-forward neural network, that is universal approximation theorem for neural networks. What it states is every continuous function that maps intervals of real numbers to some output interval of real numbers can be approximated arbitrarily closely by a multi-layer perceptron with just one hidden layer. That means with the help of any continuous activation function, we can map the inputs to the outputs with the help of a multi-layer perceptron. Okay, so if we use only one hidden layer, it is sufficient to approximate the inputs to the corresponding outputs. Okay, this means that with the help of a single layer, that is multi-layer perceptron, most of the problems can be mapped to their outputs. Okay, so this result holds for wide range of activation functions such as sigmoidal function. Okay, you can use any activation function uh, that can be applied with derivations. Okay, so that is what the universal approximation theorem says. It always says that there is a single layer of hidden layer is sufficient to map the inputs to their outputs. Okay, few more things that we need to remember is what are the learning techniques that will be used. The most popular learning technique for multi-layer feed-forward neural network is backpropagation. Okay, so backpropagation algorithm is the most famous algorithm for learning in feed-forward neural networks. We will learn it in the next session, how it works. And we also will practice few problems with this backpropagation algorithm in our coming sessions. Okay. Basically, backpropagation algorithm looks like a delta learning rule or error correction learning rule. It implies that error correction learning itself, where the output values are compared with the correct answer to compute the value of some predefined error function. So we'll calculate the error function and then we'll try to minimize that error function with the help of this backpropagation algorithm. Okay. Uh, by using this, the error will be fed back through the network, and the information of error function will be used to minimize and uh, minimize the error by adjusting the weights according to the error of time. Okay, so sometimes the adjustment will be done to the weights, and sometimes the adjustment will not be done to the weights based on how they are actually uh, reflecting on weights. So in backpropagation algorithm, we will make use of an optimization technique called as gradient descent that can quickly move towards the error minimization uh, compared to the regular delta learning group. Okay, so that is the reason why backpropagation is widely used with multi-layer feed-forward neural network. Okay, the reason for this quick optimization uh, is the network calculates the derivative of the error function with respect to the network weights and changes the weights such that the error decreases, and it quickly goes to the optimization. That is, the error becomes as minimum as possible with a few steps. Okay, so for this reason, the backpropagation is applied on networks with differentiable activation functions only. So you can see it here. Why I'm mentioning the activation functions must be derivatives of must be derivable is it is in backpropagation, derivative of the error function will be applied. Therefore, the activation function that we use in feed forward networks support this action. Okay, so that is the reason why we always prefer differentiable activation functions in backpropagation algorithm. Okay, so the people always select this logistic function because it supports this action, this operation very well. Okay. And um, once we design a multi-layer feed-forward network, we should be aware of a few problems with this backpropagation algorithm also. While training the neural network to perform well, especially when the number of training samples are very small, then it will be difficult that the multi-layer feed-forward network is properly trained. Generally, when the number of training samples are very limited, then the neural network overfits the training data and fails to capture the actual output of the corresponding input patterns. Okay, so this overfitting problem can be reduced by using a special theory called as computational learning theory, in which the training classifiers uh, are training classifiers on a limited amount of data is particularly considered. Okay, so computational learning theory helps us to properly train the feed-forward network when the number of samples are very small. Okay, so this is done by using a simple heuristic or technique called as early stopping. Okay, so early stopping helps us in overfitting, avoiding this overfitting the neural network, ensures that the network will generalize well to the examples on the training set. Okay, so with the help of this early stopping heuristic, we can generalize our neural network to avoid this overfitting problem. Okay, And another kind of problems that may occur with backpropagation algorithm is the speed of convergence and possibility of ending up in a local minimum. Okay. Because we are using that derivatives for minimizing the error function, it is always possible that it converges very quickly, and therefore it is always possible that a local minimum solution instead of global minimum may be achieved through your neural network. Okay, and to overcome this, there are some practical methods that will be implemented with backpropagation algorithm. We'll see it at the end of this unit. What are the solutions provided? Okay. Uh, in multi-layer perceptrons, the tool of choice for many machine learning tasks will be discussed at the end of this unit. Okay, we'll discuss this problem again there. And I'll tell you the possible solutions to avoid this local minimum problem. Okay, and another important point that we need to remember is we can use a series of independent neural networks moderated by some intermediary, a similar behavior that happens in brain, which can simulate the brain working. Okay, these neurons can perform separately and handle a large task, and the results can be finally combined. That means we can combine several feed-forward neural networks into a complex neural network to solve bigger problems. Okay, so that is also possible with the multi-layer feed-forward neural networks. So, having gone through the two categories of feed-forward neural networks, so that is single-layer feed-forward neural network and multi-layer feed-forward neural network, uh, there are few other types of feed-forward neural networks which may be useful while designing solutions for a given problems. Generally, any feed-forward network can be treated as a directed acyclic graph in which the connections are always from layer I to layer I plus one. Okay, we can view these multi-layer neural networks where some edges skip layers, either counting layers backwards from the outputs or forwards from the inputs. Okay, so generally there are two types now: backwards from the outputs or forwards from the inputs. You can see it like that. Uh, Various activation functions can be used, and there can be relations between weights that forms a special category of feed-forward neural network called as a convolutional neural network. So this is also a feed-forward neural network, uh, special category of feed-forward neural network. And then other category of feed-forward neural networks includes the radial basis function neural networks, where instead of using this logistic activation function or sigmoidal activation function, a special activation function is used in radial basis function networks, except that it is also a feed forward neural network uh, which works similar to the feed forward neural networks that we discussed earlier. Okay, so anyhow, this radial basis function neural network is in our syllabus also. We'll discuss about it in detail in fifth unit. Okay, and finally, sometimes this multi-layer perceptron is used loosely to refer to any feed-forward neural network, while in other cases it is restricted to specific ones. That means the name multi-layer perceptron can be used to discuss about or to represent this feed-forward neural networks. Any kind of feed-forward neural network can be named as multi-layer perceptron network also. Okay, so don't confuse between those names. Either you call it as multi-layer perceptron network or you call it as multi-layer feed-forward network. Both are going to be same. Okay, so this is about the other kinds of feed-forward neural networks. We don't have this convolution neural networks in our syllabus. We have this radial basis function neural network in our syllabus. We'll discuss it in the next unit. Okay, so this is about other feed-forward neural networks. That's all for today. Mm, So today, I hope I have given a simple introduction to what are feed-forward neural networks are, and we have seen two types of feed-forward neural networks. One is single-layer feed-forward neural network, and the other one is multi-layer feed-forward neural network. And also, we discussed about the possible activation functions in both the neural networks. Okay. In multi-layer feed-forward neural networks, hidden layers comes, whereas in a single-layer feed-forward neural network, there will be no hidden layers. The input layer neurons are directly connected to the output layer neurons in a single-layer feed-forward neural network. Okay, so the number of hidden layers in multi-layer feed-forward neural network depends on your application requirement. If the number of hidden layers increases, then the neural network becomes a deep neural network. Okay, and also we discussed about the possible activation function that might be used with the back propagation algorithm for training of feed-forward neural network. Uh, we understood that the activation function that we use must support that derivation action or operation. Uh, Therefore, we generally make use of logistic activation function or sigmoidal activation function with back propagation algorithm. Okay, and finally, we discussed about other types of feed-forward neural networks, which are very important while designing the applications. One is convolution neural network, which is not in our syllabus, and the other one is radial basis function neural network. We also understood that radial basis function neural network is same as multi-layer feed-forward neural network, except that it makes use of a special activation function. Okay. So that's all for today. Thank you all for your patient listening. We'll continue with the back propagation algorithm in our next session. Thank you all. See you again in the next class.